Welcome to lesson 2.3. So the first thing we're going to start out with is I'm actually going to show you how to FOIL in a different way. So it says it can be convenient to use the concept map of area to multiply two polynomials. And that's what FOILing is. When you multiply two polynomials, that's what you're doing. So it says, for example, label the dimensions of the given rectangle x plus 4 and x plus 7. Find the area of the entire rectangle in terms of x. So what they want us to do here is we're going to do x plus 4, x plus 7. And what we're going to do is we are going to multiply and fill in the boxes. So for example, the first thing I'm going to do is multiply x and x. I get x squared. Then I'm going to multiply 7 and x. I get 7x. Then I'm going to multiply 4 and x. I get 4x. And then I'm going to multiply 4 and 7, where I get 28. So then what you want to do is you want to add all of these up. So you get x squared plus 7x plus 4x plus 28. We can combine some like terms. So we get x squared plus 11x plus 28. So that is how you use this area model. For number 2, it says, now label and find label the given rectangle with dimensions 2x plus 1 and 2x plus 5. Find the area of the entire rectangle in terms of x. So we've got 2x plus 1, 2x plus 5. So we get 4x squared, 10x, 2x, and 5. Then we're going to want to add everything, combine like terms, and we are done. All right, so next it says, now if you were given the entire area of the largest rectangle, can you label the dimensions of the rectangle? So what we have to do here is, let's take a look. We're going to put our x's down because we know that this guy, this x squared, he always comes from this box here, right? And if we got x squared, we know it's just going to be 1x times 1x. Then let's take a look. We know that this box here needs to give us 18. That's where that constant comes from, is it always comes from this box here. All right, so we know we need to get an 18 in this box. Now, this middle term comes from adding these two terms. So essentially what we want to do in order to find out what two numbers we're missing is let's think about what two numbers would multiply to give us 18 but add to give us 11. So first, let's write out some factors of 18. We've got 9 and 2, 6 and 3, and 18 and 1. So we know that we could use any of these combinations to give us an 18 here. So what we need to do now is figure out, okay, well, which one of these combinations is going to add up to give us an 11? It's going to be this guy here. So we're going to have x plus 9 and x plus 2. All right, so that would give us our 9x, and that would give us our 2x. So the two binomials we would start with is x plus 9 and x plus 2. All right, let's do the same thing for this guy. We know we're going to have an x here, we know we're going to have an x here, and that's how we're going to get our x squared. We know that this 40 goes here. So we have to figure out, okay, what are some different things I can multiply to give me 40? So some examples are maybe 4 and 10, 8 and 5, 2 and 20, and 40 and 1. So I have to see which one of these combinations is going to add, so it's multiply to give me this, add to give me this guy. So which one of these pairs is going to add to give me a 13x? Well, that's going to be the 8 and the 5. So we get 8x, 5x, and our binomial would be x plus 8 and x plus 5. So now let's go ahead. It says multiply the following polynomials and combine the like terms. So what I'm going to do is for the first ones, I'm going to use the area model. And for the second one, I'm going to, or I should say, for the ones on the left-hand side, I'm going to use area model. The ones on the right-hand side, I'm actually just going to FOIL out or distribute. All right, so for this one here, ooh, that is not what I drew. All right, so we'll draw our box. We've got x in 11, x in negative 12. So we get x squared minus 12x plus 11x minus 132. So then we need to combine all of our like terms. We've got x squared plus 11x minus 12x minus 132. We get x squared minus x minus 132. All right, next one. So for this one, I'm actually going to FOIL out. I'm trying to show you the two different ways you could do this. So let's go ahead and FOIL. So we've got 20x squared, 8x, 15x, and 6. So then when I combine my like terms, I get 20x squared plus 23x plus 6. All right, let's try the next one. We'll use the area model. So we draw our little square, put in our boxes, and we've got 2x plus 3 and 2x minus 3. So we end up with 4x squared, 6x, minus 6x, and negative 9. So we've got 4x squared minus 6x plus 6x minus 9. 4x squared minus 9. Those two middle terms cancel. All right, now let's try 7. So one thing I want to point out here, please, if you have a plus or minus sign in here, never just distribute the square. This does not equal 4x squared plus 25. Please never do that. It'll make me very sad. What you have to do is write this out twice, right? Like 2 squared is the same as like 2 times 2. So that's what you have to do is write this out twice. So you get 2x plus 5, 2x plus 5. Then we will go ahead and FOIL. So we got 4x squared plus 10x plus 10x plus 25. So you've got 4x squared plus 20x plus 25. All right. So for this last one, it's a little bit different. Instead of 2 binomials, we have what's called a trinomial. You see how it has 3 terms? That makes it a trinomial. Doesn't make it that much harder, just a little bit more work. So first we'll do it using that area model we just learned. So we'll set it up, but instead of only having 2 on top, we're going to make 3 because we have 3 terms. So we got 4x squared minus 7x plus 2, 3x, and a positive 8. So we end up with a 12x cubed. Notice how it's a cubed because we have an x times an x squared. Then we end up with a 32x squared, negative 21x squared, and a negative 56x. Again, this 21x was squared because there's 2 x's. Then with negative 7x and 8, we get negative 56x. 3x and 2 gives us a 6x. And 2 and 8 gives us a 16. So we're going to go ahead and add them together. All right, we're just going to combine like terms. So these guys can get combined, and then these guys can get combined. So we end up with 12x to the third plus 11x minus 50x plus 16. Now you can do this by using that FOIL/distribution method as well. And I'm going to show you that too because I do think it's important to know how to do that. So you get 4x squared minus 7x plus 2 3x plus 8. So how you do this is you're just going to go down the line and distribute each of these three terms to each of these guys. So let's go ahead and try it. So we'll do 4x to 4x squared to 3x, we get 12x cubed plus 32x squared. Then now we have to distribute the negative 7, so we get minus 21x squared. Distribute that guy, we get minus 56x. Then we've got the 2, so we got plus 6x. And then our last one, we've got 16. All right, and then again, you just combine like terms. And that is another way to do that same problem if you don't like drawing the boxes. Whatever works for you, do it. All right, so the last couple problems, it says identify the x-intercepts of the parabolas below. So what they mean by x-intercepts, the x-intercept is where this function hits the x-axis. So if you look at this first one, we hit the x-axis here and here. So when you write the x-intercepts, you want to write them as points. So we hit the x-axis at 0, 0, and, oops, 2, 0. All right, so that would be our two intercepts here. For the next one, we got to look at where this parabola hits the x-axis. It doesn't. All right, so the answer here would be none. It doesn't have any x-intercepts. All right, this next guy, we have an x-intercept here and an x-intercept here. I do apologize for the poor quality of these numbers. I tried my best. So the first one is going to be 1, 0. The next one is going to be 3, 0, right? We have 1, 0, 3, 0. Then our last guy here. This one only has one x-intercept. So when you're dealing with parabolas, you can have two x-intercepts, one x-intercept, or none. In this case, we have one x-intercept, and that's going to be at -2, 0. So basically, you have one x-intercept when the vertex is on the x-axis. Then, you know, you could either end up with two or none, depending on where the